page 626. I don't think this needs a lot of introduction, so we'll just jump right in. I didn't mean 10, I meant 8. Oopsie.
Right there, are you sure you didn't mean 6?
And by 6 you mean 2?
And by 2, I mean 20.
Okay.
Okay. Number 1. So, what does that symbol mean? Who knows? What a mystery.
Oh, that's pedaz.
No. This week, oh goodness.
This one goes all the way to H.
Yeah, no way.
That's easy though. Okay. Oh, I put the wrong letter. No, I didn't. So this means what's the probability of x not happening? So P of x means what's the probability of x happening? P of x prime, that little apostrophe thing, means what's the probability that x won't happen. So let's say the probability of me going to Tulsa is 30%. So what's the probability of me not going to Tulsa?
70%.
70%. So these two have to add up to 100, right? So the probability of x and the probability of not x always have to add up to 1, like 100%. So if you look at that little tree diagram right below there, it says, basically it says the probability of x happening on that first line is 0.4.
So it'd be
So what's the probability of not x happening?
0.6.
0.6.
Can we do the dartboard and all that? Because the glare's really bad.
Yeah.
Something.
You want to do the lights off or the dark board?
I don't know. Wait. What do we usually do?
We do lights off too. We don't really do this, but
Yeah, we're not gonna do this.
Let's
Yeah.
try the dark.
You want to try the dark board?
Yeah.
See what that looks like.
The glare is still. I don't know why it's bothering me.
Now it'll be really dark.
And it's not too bad.
you nearly adopted the dog. I was bored.
I guess it's pretty. So, show good.
Yeah.
Okay. Forgot what we were talking about.
So A is 0.6.
Yeah, A is gets 0.4 and what add up to 1. So does that make sense where we got that from? Okay. B. So B has another new notation. So B means what's the probability of not y happening given that x has already happened. You guys get that? Listen.
Yeah.
B means what's the probability of not y happening if x already happened. That's what-
0.7.
So basically you go down the x line and then go down, look where the blank is on not y. So if the possibility of y happening is 0.3 and the possibility of not y happening is 0.7. Okay, C. What's the probability of not y happening if not x has already happened?
0.5.
0.5. So we're on the right side where it says not x, and then you go down to not y, that blank, which is across from 0.5. What adds up to 1 with 0.5? 0.5. D. What's the probability of x and y happening? So in other words, the first thing that happens is x happens, and then the second thing that happens is y.
Don't you multiply them together?
Right.
So,
So
it'd
the
be
probability of x happening is 0.4.
times 0.3, which is
Yeah.
0.12.
Probability of y happening right after that is 0.3. 0.4 times 0.3. A little x right there. Is 0.12. 12% chance. That's got a lot of letters. E. What's the probability of not x and y happening? What was the probability of not x? Point six, what was the probability of not y right after that?
0.5, so it's 0.3.
Point 30 or point 30? Okay, what's the probability of y happening? It's kind of a trick question. There's two ways that y could happen. It could be x and then y, or it could be not x and then y.
So do you multiply
And
together?
you add those two probabilities together. So what's the probability that x and then y happens? We just found that on D. 0.12.
0.12.
What's the probability that not x and then y happens? We haven't found that one. Oh yeah, we did. That was the last one. That was 0.3. So the probability that either this one
0.42.
or this one can happen is Adam, yeah, 0.42. 42% chance.
Because you multiply them together?
No. So this is the probability of getting, if x happened and then y happened, that was that probability. This is the probability of x not happening and then y happening. So the probability that it does one or the other is those two added together.
But
12% chance it could go down that left-hand route. 30% chance it could go down that other route. That it happens to has to work on one of these, it would be a 42% chance.
Okay.
Does that make sense?
Yeah.
Kind of. We'll settle for kind of. A, B, C, D, F, G, and H. Okay. G means what's the probability that X happens if Y has already happened? Oh, well, not already, but is guaranteed to happen. So X happens given that Y is going to happen. Was it 3? Given that Y is happening. Well, let me think. It's 50% of Y's are backwards. Probability of X given Y. Probability of Y is 42% chance. Somebody plug that one in. What do we get?
Point 252.
252?
Yeah.
It's close, but it's not.
0.42 times 3 for this.
Yeah.
Yeah.
Try again, Chief. I might have to come back and look at that one again. Probability that X happens, or happen, if Y is going to happen.
Wouldn't that not change?
No, it does change. Let's see. So let's think of it this way. What's the probability that XY happens? That was 0.12. What's the probability of not XY happening? That was 0.30. So both of these X happened. This is the one that happened with Y. 12 out of 30 reduces to 1/5. That's not it either. what's that as a decimal?
0.285.
Yeah, that's it. Yeah, great, now I gotta explain.
12 out of 42 is a decimal.
Okay, yeah, 0.286 is what they put. Gosh, this is hard. So, both of these possibilities is where X happened. But this one is where the Y, this is where X and Y happened, and this is where not X and Y happened. So these are the two routes that we could go, and basically I did, we want the odds of this, if one of these two is gonna happen, what's the odds that this one is gonna happen? That's basically what's happening here. So I did 12 out of 42, I added them together. I don't know if there's an easier way to explain that. So there's a 12% chance X and Y happened here. Then there's a 30% chance that, what was this, not X and Y, happened over here. But they're saying, given that one of these is gonna happen, what's the odds it's gonna be this one? So it was 12 out of the total, 42. Anyway, so yeah, which reduces to, don't worry about it, 0.286, we'll just keep going here. I bet B is probably pretty similar. What's the probability that not X will happen, given that Y does happen?
So that's just 36 over 42, or 30 over 42.
Well, hold on, let's see, 30 over 42.
That's 0.714.
Yeah, I should have kept that up there that I just erased. Let me put that back. There we go. Yeah, so basically, if one of these is gonna happen, what's the odds that it's gonna be this one? So it'd be 30 out of 42. Yeah. What'd you say it was, Matthew?
0.714.
Yeah. I might have to help you guys with G and H on the other one. Is it that same idea? Probability of R given J.
So the answer is 0.714?
Yeah. No worries. Again. 0.714. Oh gosh, look at all those letters. Okay, let's do two G and H, I guess. So this is just using the other picture. What's the probability of R given J? So the probability of R and J happening is what? Let's start with that. 0.7 times 0.3, right? What's the probability of,
Do you always multiply them together?
if you want both of them to happen?
Wait. What are we doing?
2G.
We're just doing G and H.
I thought we were doing
Why
2D.
0.3?
Huh?
It's at the example 2. Like the top
You
right.
said 0.7 and 0.3.
Yeah.
J is 0.5.
Just 2 days.
Am I looking at the wrong side?
Oh.
No.
It's on the
Probability
left
of-
side. Where's the left side?
I'm R and J happening, so I'm on the left side.
So R is so it's 0.3 times 0.7.
Okay, and then the probability of S and J happening
0.345.
is, yeah, 0.3 times 0.5 is 0.15. So they're saying, given that J happens, these are the two ways we can get J. Given that J has happened, what's the probability that it's going to be R over here?
Wouldn't it be 21 over...
21 out of, 21s are target.
21 out of 36.
Out of the total 36. Let's go ahead and turn all these to decimals though.
Which number was that?
G, 2G.
So
I
that
figured out,
one's
we'll
where-
just knock out the two hard ones on number 2 and then keep going.
Is it 0.583 repeating?
Yeah, 0.583. Okay, and then H is kind of, given that J happened, so these are the two ways J could happen, what's the probability that S happened? So
It'd be
15 out of
4,
36.
What'd you get, Matthew?
0.417. This is 0.583. There's Trixie.
Trixie little hot.
Okay, so this was G and H for number 2. Let's knock those out. All good. Number 3.
I don't think we're gonna get through this.
Use the tree diagram at the right to find each sum of probabilities. Okay, what's the probability of A and D happening?
0.5 times
0.5 times 0.1.
is
0.5.
is 0.5.
Well, no.
Oh, 0.0.5.
Yeah, 0.05. So it's like a 5% chance. There's a 50% chance that A happens, and there's a 10% chance after that D's gonna happen. So 50% times 10% is 5%.
Wait, can you say that again?
Well, I'm just looking at the picture here. There's a 50% chance that A is gonna happen. And then after that happens, there's a 10% chance that D is gonna happen. So what's the probability that A and D happens is 50% times 10%. Small plug together. So it's 5% plus, what's the probability that A and E happens?
0.5 and 0.9.
0.5 times 0.9.
When I added them together, I got 0.5.
0.45, yeah, you add them together. Okay. Can anybody tell me why there's a 50% chance that both of those together are gonna happen?
Because there's a 50% chance that it'll go to A.
Right. There's a 50% chance A happens. So once you get to A, if you go left or right, yeah, there's a 5% chance, 45% chance. Together they make that 50% chance. So if you're talking about A happening, you got a 50% chance, basically. Everything that happens under A should add up to 50%. B, what's the probability of B and D happening? This is A, number 3. B and D. So B is 0.4, and then D is 0.7. What's 0.4 times 0.7?
I had it.
0.28.
0.28. So all you do is 4 times 7 and move the decimal twice. 0.28. You don't need a calculator for this. Plus, what's the probability that B and E happens? 0.4 times
0.12.
0.3, 0.12.
It just adds up to 0.4.
Adds up to 40% chance.
So would,
Because
Okay,
this
I
is
don't
like
get that
saying,
part. Why does it?
Huh?
Why does it?
because
go
it's
to
both
that?
probabilities under 1.
yeah, because there's only two things that could happen after you go the B route. You go left or right. But that is just like saying you went the B route. So there's a 40% chance. These two things together make up the B route. Like this represents B and D, this represents B and A. So together they represent like B in total,
Oh, okay.
which is 40%. Okay, so C, you kind of need to understand that to do C. What's the probability
Wouldn't C
of
just be
C and D?
0.1?
Well, we don't know exactly, but whatever the probability of C and D happening is the same as probability of, and probability of C and F happening,
That's just
or C
0.1,
and
right?
E happening.
Why is that?
Okay, the top line, the ABC, should add up to 1, because you got a 100% chance of A or B or C happening. So 0.5 plus 0.4 plus what equals 1?
So it's just
0.1.
1. So probability of C and D and the probability of C and E should add up to the probability of C, which is just 0.1.
So it's just 0.1.
Yeah. No, number 5. Jar A contains 2 red balls and 3 white balls. In the picture there. Jar B contains 4 red and 1 white. A coin is tossed. If it shows heads, A ball is randomly picked from jar A. If it shows tails, a ball is randomly picked from jar B. Draw a tree diagram to show the probabilities of each jar and then the probabilities of picking a red or a white ball. So I think we need heads or tails up front. And then we go. Alright, so this is number 5. Okay. Yeah, what's the probability that we get? What's the probability that we're going to use jar A to coin flip? 0.5. So we need to label it. So this is jar A, this is jar B. And then once we're in jar A, what's the probability that we'll get a white ball?
1/5.
No.
Oh, I'm thinking of jar B. 2/5. 3/5.
3/5. You guys know what that is as a decimal? I guess we could use fractions, but I'm going to stick with what they're using. 3/5 is 0.6.
Yeah.
Like 16ths. So if this is 0.6, what's this one got to be? 0.4. How should this is white and this is red, right? Yeah. And if we go jar B, what's the chances that we're going to get a white?
1/5.
1 out of 5 or
0.2.
0.2. You could use fractions, I don't care. And then that leaves 4/5 or 0.8 for this one. That's it.
Wait, how'd you know it was 0.2 and 0.8?
Because in the jar B,
Oh,
1 out of 5
okay.
of the balls are white,
Uh-huh,
and 1 out of 5 as a decimal is 0.2.
okay.
And then 4 out of 5 are red, so that goes to 0.8. Anyways, question B was, what's the chances of getting a red ball? So the chances, so there's 2 ways that could happen. We could get jar A and then a red, or we could flip and get jar B and then a red.
So it's
What's the
0.4
chances of
times
getting A and then a red?
0.5 times 0.4,
0.5 times 0.4,
which is 0.2.
0.2.
So we add that
Plus,
to
yes,
0.5.
what's the chance of getting jar B and then a red? 0.5 times 0.8?
0.6.
No. Oh, 0.4. And then you add those together, there's a 60% chance of getting a red ball.
Do you want us to put 60% or can we just put the decimal?
I've just been putting the decimal in there.
Wait,
And I
Really?
think it's helpful to, know what this means, like in terms of percentages, because we understand this a little bit better.
so it's 0.5 times 0.4 plus 0.8 times 0.5?
Mm-hmm. Okay, so next one, what's the
Oh,
chances?
I'm done.
No, it's different. If a red ball is picked, so like given that there's a red ball, find the probability that it came from jar A. So this is like the hard one, so we did 1 and 2. So there's 0.2. It's given that one of these had to happen if a red ball was picked. So it's either this 0.2 or 0.4. So what are the chances that it came from this one as opposed to this one?
It'd be 0.2 out of
2 out of
6,
6,
which is just 1/3.
which is 1/3. You guys know what that is as a decimal?
1 through repeating.
Okay, number 7. Machine A produces 60% of the ball bearings manufactured by factory, and machine B produces the rest. 5% of machine A ball bearings fail to have the required precision, and 2% of machine B bearings fail. draw a tree diagram. So we have machine A and machine B. What's the odds that the ball bearings are gonna come from machine A?
0.6.
Yes, they said 60%. So what's the odds that the ball bearings are gonna come out of machine B?
0.4.
0.4. Okay. Given that they come out at A, what's the probability that, what do we call it, good, bad? No, let's call it good, not good. Okay, what's the probability that the ball bearings coming out at A will be good?
95.
95%?
Yeah, 0.95.
Because it says 5% fail, so that means 95%. Whoops. Okay, I'll call it good and not good. So 95% are good, that leaves 5% are bad. And out of machine B, what's the probability that they're good? Is it like 98%? 2% are bad, so 98% are good and 2% are bad. Okay, that was A. B. What percent of the bearings fail to have the required precision? So maybe I should call it fail. The not good here is my fail. So it could happen out of machine A 60%, 5% of 60%. Whoops. Or it could happen out of machine B, which happens 98% of the 40%.
I got 0.038.
Yeah. What's 0.038 as a percent?
3%, or almost 4%.
3.8%. Okay, C. If a bearing is inspected and fails to have the required precision, what's the probability that it was produced by machine A? Okay, this is back to. So this represents failed bearings out of machine A, which, what does that come out to?
3 over 100.
3%. Okay, this represents failed bearings out of machine B. Oh, that's a tough one. What does that come out to?
0.8%.
Yeah.
Point.
0.98 times 0.4.
Point 392.
Did you multiply that times the 0.03? Or just the 0.98 times 0.4?
Okay, this, well, okay. Point four, yeah, that sounds right.
No, it's wrong.
Oh,
We did the good ones.
we did the good ones. I was gonna say that is making sense.
That's what I was saying. It should be a lot
Okay.
smaller.
Yeah, sorry, we did the good ones. So we need to do the bad ones, basically.
Well, you have one bad and good. We just
Yeah.
need to do 0.02 times 0.4. Instead of 0.98.
Oh, yeah, you guys didn't listen to me. That's why it worked. I went the good route. I should have went the bad route. Whoever told me did it themselves. Okay. Yeah, sorry, it should have been that right there.
Wait, so that whole thing was wrong? Like B?
No.
This
No.
was wrong over here. The
Point-
answer was right.
The point answer was right because I plugged in the good way.
I just wrote the wrong thing down. Okay, so basically,
Adding them together would be 0.1, 0.11.
0.11. This means like 3% of the time that you get a ball bearing, it'll be bad out of machine A, and then 8% of the time you get a ball bearing, it'll be bad out of machine B. So, given that we have a ball bearing, what's the odds that it comes out of machine A? So that's basically 3% out of 11, 3 out of 11, if you add them together. What's 3 out of 11 as they just put a decimal on this one for whatever reason.
0.27. Repeating.
Is that wrong?
Seems
How is that
kinda
wrong?
Is,
The bearing is suspected to have required precision. What's probability that it was in machine A? We put their percentages on the right one. 60% ball bearings go to machine A. 5% machine A's fail. 2% in B fails. Yeah, I'm starting to wonder if the book made a mistake on this one. They did they put .789, which would be like the odds that the B machine would.
But machine A should produce more wrong ones, because B is more accurate. So that sounds right.
0.0008.
yeah,
Or
when
zero,
you do
zero.
0.4 times 0.02, it's not 0.08.
Oh, I missed a decimal spot. Oh yeah, that's right, isn't it? Okay. My bad. Okay, so it's more like .03 out of .038.
3.8.
If you have those together, that's the total.
I was gonna say, how did you get that?
That's 79. 0.79.
Yeah. Okay. Yeah, fine. Close with that. 79%.
Okay, can I go to the bathroom?